Hello everyone, we are Team Stormbreakers. Our project is evaluating efficiency in humanitarian funding. The core idea is simple. When humanitarian funds are limited and needs are vast, how do we ensure money is reaching the maximum number of beneficiaries efficiently? We propose a data driven, standardized framework to help answer that. Humanitarian funding operates across many countries, clusters, and donors. Because of differences in scale, geography, and program design, comparing efficiency across projects is extremely difficult. Today, there is no simple, transparent metric that allows decision makers to consistently evaluate efficiency. Our goal is to fill that gap. We use three UN datasets: CERF allocations, donor contributions, and CBPF project level data. Our key metric is cost per beneficiary, calculated as implementation cost spent divided by beneficiaries reached. Because costs are highly skewed, we use log scale normalization and detect statistical outliers using the interquartile range method. Before dividing into visuals, three headline findings stand out. First, cost per beneficiary varies widely across projects. Second, allocation categories show very different efficiency patterns. And third, some categories consistently show both high median cost and high variance, suggesting deeper structural or contextual factors. This chart shows the distribution of cost per beneficiary across all projects. On a log scale, we see a clear right skewed distribution. Most projects cluster around a relatively narrow efficiency band, but there is a long tail of very high cost projects. Here, we break down cost per beneficiary by allocation type. The medians differ substantially across categories, and so does the spread. For example, logistics heavy or coordination focused categories show higher median costs and wider variability than frontline service delivery. This scatter plot shows implementation costs versus beneficiaries reached. Most projects fall within a predictable efficiency band. The highlighted points are statistical outliers, projects whose cost per beneficiary is unusually high or low relative to peers.
Next, we look at efficiency across regions and country-based pooled funds. Some regions consistently show higher outlier rates. Median cost per beneficiary also varies meaningfully by cluster. Importantly, high outlier rates may reflect inefficiency or they may reflect conflict intensity, access constraints, or fragile infrastructure. This chart compares the top 10 allocation categories by median cost per beneficiary, shown on a log scale to handle large differences. Each bar is the median and the error bar shows the interquartile range. Logs and CCS stands out with a much higher median cost, reflecting fixed logistics and coordination cost, while frontline and pipeline services cluster around $10 to $12 per beneficiary, indicating more consistent delivery efficiency. This provides a clear standardized benchmark for comparing efficiency across categories. Here we focus on country-based pooled funds. On the left, we see outlier rates. On the right, we see median cost per beneficiary. Some contexts, such as Ukraine, show both high median costs and high outlier rates, which is consistent with operating in high-intensity conflict environments. We then zoom out to the global donor landscape. A small number of donors account for a large share of total CERF funding. This concentration contrasts with geographical diffuse nature of humanitarian needs. Understanding this imbalance is crucial for long-term resilience planning. This global map visualizes total CRF donor contributions by country. Contributions are highly uneven, with a small number of countries providing the majority of funding. This visualization helps contextualize funding capacity and global responsibility. This chart shows how CERF funds are allocated across humanitarian clusters. Food assistance and health dominate allocations, reflecting urgent humanitarian priorities. Linking these allocations with efficiency metrics helps ensure funds are not only well intentioned but well deployed. Based on our analysis, we propose a simple scalable framework. First, compute cost per beneficiary for all projects. Second, normalize using log scaling and flag the statistical outliers. Third, compare efficiency across clusters, regions, and time. This framework is transparent, data light, and adaptable. To conclude, our framework enables evidence-based monitoring of humanitarian efficiency. It supports transparency, accountability, and adaptive allocation without oversimplifying complex realities. Most importantly, it helps ensure that every humanitarian dollar reaches as many people as possible and as effectively as possible. Thank you.